Hello everyone, welcome to my Chemistry in Captivity video. We will be exploring the importance of chemistry in restorative dentistry. Here, we can see an example of a cavity that has been prepared for restoration. Our first step involves a 40% phosphoric acid gel suspension. Since enamel has a mineral content as high as 96%, phosphoric acid interacts with the surface of the tooth and has two major effects. First, it changes the surface morphology of enamel by forming micropores that allow the bonding agent to penetrate the enamel. The resulting structure of the tooth resembles a honeycomb pattern, greatly increasing surface area. Second, it increases the negative charge on the enamel surface and facilitates the chemical reactions of NDP adhesives and hydroxyapatite to produce more calcium salts, thus improving the chemosorption between enamel and the adhesive. Next, a desensitizer is applied for two benefits. Luma, 5% glutaraldehyde, and 35% hydroxyethyl methacrylate inhibit the flow of fluid through the tubules, which is the cause of sensitivity and provides a seal that acts as a microbial barrier. Afterwards, the bonding agent is applied that promotes chemical and mechanical retention of the filling material. Scotchbond, MDP adhesive, contains multiple chemicals that work together to obtain ideal chemistry for bonding and working in a moist environment. During application, the bond is hydrophilic and allows the bond to be placed without worry of the prepared tooth getting wet. Once cured, the bond becomes hydrophobic and expels any residual moisture that may have found its way onto the tooth. Curing of the bond with a light cure creates pronounced resin tags and better micromechanical interlocking between the tooth, bond, and filling material. Photopolymerization is a light-activated reaction that uses visible light energy to activate the photoinitiator system, which absorbs light photons and produces reactive species that initiate the polymerization process. One of the most commonly used photoinitiators in dental resins is camphorquinone. Camphorquinone is produced by the oxidation of camphor with selenium dioxide and is responsible for the activation of curing dental resins and bonds. The peak absorption range for CQ is from 455 to 481 nanometers, with peak absorption at approximately 469 nanometers. It takes 20 joules per square centimeter or 20 joules of light energy deposited on the area of resin to properly cure most materials. This step involves preparing the interproximal band that helps rebuild the back wall of the tooth. It isolates the removed tooth structure and creates an ideal shape for the dental resin to refill the tooth. By positioning the special clamp, it creates tension on the tooth and ensures perfect contact with the neighboring tooth once removed. Finally, the composite material is ready to be placed into the prepared tooth. It has like a putty-like texture, allowing us to shape and place the filling material exactly how we want to recreate and replace the damaged tooth structure. Once it is condensed into the shape of the tooth, it can be cured with the UV light and sets to a similar density as natural enamel. In this situation, a polymethyl methacrylate polymer is the main component of the filling. The same chemical that makes up everyday things, such as plexiglass, is also used as the bulk of modern-day filling materials. Its strength and durability work excellent for copying tooth strength and stability inside the mouth. Other chemicals, such as ytterbium fluoride and ethylene dioxydiethyl dimethacrylate, are used for ease of identification on X-rays and as a free radical copolymer cross-linking reactions. Here's a short break to just watch me place the filling. No difficult words, just some music. Longevity of the restoration depends on many factors, from personal oral hygiene to the accuracy and precision in which the filling was prepared and placed. Now that all the materials our chemist friends have developed for us is cured, the filling is finished and ready for structural shaping and polishing to obtain a natural feel and fit. If you would like to learn more, please see the links I've included below. They contain research on how each material works, as well as specifics from the companies that manufacture them. Next time you must get a filling, now you know the extensive research and development that went into the chemical reactions and compositions of materials to make sure that you can keep eating like nothing ever happened.